Hi everybody. So today we're going to continue with probability and we're going to focus on something called the multiplication rule. But before we look at that, we have to talk about the difference between independent and dependent events. So you're going to see linked in the Google Classroom assignment, there's going to be this video here that you can watch. It's a YouTube video. And independence means that the outcome of one thing does not influence the outcome of another thing. So something like rolling a die or flipping a coin, what I do the first time has no effect on what happens the next time. So let's get that definition here. So independent events. One event does not affect the likelihood of the second event occurring. So like I said, an example would be rolling a die or then flipping a coin. Whereas dependent events, one event does affect the likelihood of the second event occurring. So this would be like if you're dealing cards. Let's say you're playing a card game and you draw an ace and then you draw another card, but you don't replace the ace after you draw the first one. Well, as soon as you're not replacing things, you're changing the probabilities for the second event happening. Now, let's take a look at the multiplication rule for independent events. So this is when the events are not affected by something else happening. So the key wording you're going to look for here are things like putting the marble back, and you can see that I underlined, oops, that's not an underline. Sorry, technical difficulties. Let's get back to where we were. Okay, multiplication rule. All right, so putting the marble back here is the key wording that I'm looking for. Or a problem might say something like with replacement. So the rule that we're going to use is we're going to multiply. So I want you to think when you're doing these and probabilities, and is multiply, as opposed to the problems we've done earlier where we're trying to calculate the probability of A or B, then we added. But with ands, we multiply. So if the events are independent, you can just multiply the individual probabilities. So if I have a marble that has 5 blue, 4 white, and 3 red marbles in it, I have 5 plus 4 plus 3, so there's 12 marbles all together, right? So you want to add everything up and say that's what's in the total. And what we're going to do is we're going to draw 3 marbles in a row, 1, then 2, then 3, but we're going to put the marbles back every time we draw them. So what is the probability that you get a red followed by a white followed by a blue? So this is an and problem. These are independent events. So we need to multiply each of these individual probabilities. So since there's 12 marbles in total, there's a 3 in 12 chance of getting a red. There's a 4 in 12 chance of getting a white. And there is a 5 in 12 chance of getting a blue. And multiplying those all together, we'll end up with 0.0347, or about 3.47%. Let's look at another example here. Jesse has a deck of 52 regular playing cards and a bag of 6 marbles. In the bag, there are 2 blue marbles. So let's see if we can draw the bag of marbles he has. He has 2 blue marbles. He has 3 green marbles and 1 white marble. Well, I don't have a white marker, so I'll just do that. What is the probability of drawing an ace from the deck? Well, if this is our deck of cards over here, the probability of getting an ace out of a deck of cards is 4 out of 52 because there are 4 aces. So this is the probability of getting an ace. Now over here, on the right, we have our bag of marbles. And what is the probability of getting a blue marble from the bag? Well, the probability of getting a blue marble is however many blue marbles there are, 2, out of the total number of marbles, which is 6. So this question is asking, what is the probability of getting an ace? Oops, what is the probability of getting an ace and a blue? So an ace followed by a blue. And because these are independent events, what happens with the deck of cards has nothing to do with what happens when we pull the marble. We're just multiplying the individual probabilities. And that's how we do multiplication problems for independent events, or probabilities with independent events. Okay. Now let's take a look at dependent events. Well, actually, no, here's another. Let's do one more independent event rule. So we are trying to find, in this case, the probability that Andrew and Ellen will both drive to work. So let's look at the problem. The probability that Andrew will drive to work tomorrow is 72%. The probability that Ellen will drive to work tomorrow is 92%. What is the probability that Ellen and Andrew, so again, focus on this wording, and, so think to yourself, this is a multiplying problem, will both drive to work tomorrow? Ellen lives in California and Andrew lives in New York. They do not know each other. Okay, this is important because these sentences right here tell me that these probabilities that they will drive, these are independent events, whereas if Ellen and Andrew were married or something, then they wouldn't be. So what we're going to do is the same rule we've been talking about. The probability that Andrew drives and Ellen drives is the product, or just multiply their individual probabilities. So 0.7 times 0.92 equals 0.6624. All right, one more. Miss Downs can shoot a free throw and make it with 45% accuracy. So what that means is that the probability I can make a free throw is 45%. It's probably lower than that. I'm really not a very good basketball player. All right, so the probability of making a free throw is 45%. What is the probability that she shoots and makes 5 in a row? Well, 5 in a row means making the first and the second and the third. So this is an and probability where I'm looking at making a free throw and another free throw and another free throw and another free throw and another free throw. Now, for this problem, we're going to assume independence. So let's assume that every time I shoot a free throw, I have a 45% chance of making it in. Now, I know you could argue, well, you're going to get better as you go along, but let's just, for the sake of the problem, say, no, I have a 45% chance of making it every single time I shoot, which means these are independent events, which means I'm multiplying the probability of getting a free throw the first time times the probability of getting a free throw the second time, which should be a P, and we'll just do this 5 times. And so if we do this 5 times, we're going to be doing 0.45 times 0.45 times 0.45, or in other words, this is 0.45 to the 5th power. And that's what we'll get if we multiply 0.45 5 times. So 0.45 to the 5th power is 0.01845. So there's about a 1.845% chance that I would make 5 in a row. Not very likely that that would happen. All right, so the video recorder that I'm using cuts off after a certain amount of time, so I'm going to stop this video. This part is just on independent events, and now I'm going to make another video related to dependent events so you know how to do those.